Hi, we're the Emotiv headset group. I'm SRUTI. I worked on PsychoPi as well as facial expressions on VS.
Hi, I'm ADVAITH. I worked on the Cortex Api as well as working with the actual headset itself.
Hi, I'm Roger, and I work with ADVAITH on Cortex API, and I also worked on mental command training.
I'm Daniel, and I worked on the keyboard and mouse cursor movement program. So what is it and how does it work? So basically our project is a program that allows the user to type words with their mind and using facial expressions using a virtual keyboard. And in our project, we use the ease of access keyboard on a Windows laptop. And the main element of our project is the Emotiv Insight headset, which records brainwave activity and facial expression data. And using the software, the Cortex API software, which connects and allows the headset to communicate with the Cortex service, we were able to train the headset so that it detects brainwave activity and facial expressions of a specific user. And in our project, ADVAITH was the main user. And using the live stream of data we get from the various facial expressions from the user, we were able to run our program and simulate mouse cursor movement on the virtual keyboard to simulate typing. And for example, if the user winks with their left eye, then the mouse cursor moves to the left. And if the user frowns, then the cursor moves down on the keyboard.
So I focused in more on PsychoPi. I know when I was doing some research on the Emotiv headset, I came across several articles talking about how this headset could be used with PsychoPi, which is an application mainly in psychology research. And the reason I wanted to use this in the first place is that over the summer at my EXP in my lab, I used PsychoPi for a majority of it. So I already had the background and have done other programs in it. So it would be a lot easier for me to write programs with this Emotiv headset in PsychoPi. So there is different views of PsychoPi. You have the coder view, which is directly in Python, as well as you have the builder view, which is over here, which allows you to use different stimuli like images, text, sounds, and keyboard, which was a main aspect of our project. And you can also control the timing of it to allow like a stimuli to appear on the screen for a certain time, as well as display like an image. And then down here, you have like the loops and routines of the order of your different code. So a loop essentially is if you want to run like an image this many amount of times, if you put a loop in, it will display that image that many times. And then the routine is like the entire program running again.
So I will talk briefly about Cortex API, which is the user interface that we use. And the first step is to get the license information on the terminal. And we first by connecting the headset to our laptop and created a record on the VS Code. And then the next step for us is to train the mental command training and the facial expression training through the codes we wrote on train.py and facial expression.py. And after that, we basically just created, updated, and exported the data that we need to implement like our task. And in this case is to move the cursor on the keyboard to type. And here are some of the problems that we faced. So the first big problem was poor documentation. So because we have some example code from API example.py, but I didn't work out very well in the end. So we have to write most of the code by ourselves. And because of the poor documentation, it's hard to like use anything that's being like written on the documentation that they get. And the second problem was about the headset. So the Bluetooth sometimes doesn't work during class. So it's not like very efficient for us to work on it. And we also have some trouble with the EEG quality. So basically EEG quality is just the contact quality when you are trying to like wear the headset and use it for our purpose. And because the EEG and contact quality wasn't very stable, we have to like spend time and fix it. And after that, there are also like battery problems. and the headset only works for ADVAITH because all the previous models were based on his data. So it makes it a little inconvenient.
So basically, so my next goal was turning like the facial expressions data that we received into emojis using VS Code. So the issue that arose with PsychoPi was the fact that it doesn't use live data. I had to upload a text file already and send it in through the program. So when we're using this headset, if you want to smile, you would have to smile essentially and then upload that data instead of like you smiling and the emoji appearing. So I switched to VS Code. So it was using a JSON file, which is in a Python package. So previously to this project, I've never worked with it. So I did have to spend some time researching as well as understanding how the text file works. And then I wrote some code to read the text file and then use it into displaying emojis. But then there was another problem, which was the fact that our main project, which was the keyboard, started using the facial expressions. So that big project and then my sub project overlapped, because if you were to smile, it would also move the cursor as well as display an emoji, so it wouldn't work simultaneously. So we kind of had to put a hold on that, and we kind of like hope in the future in the next term to figure it out how to like put both projects together.
So the main part of the project that I worked on was the keyboard and mouse cursor movement program. And the majority of this program was written in PyAuto with the library PyAuto GUI, which is a Python library that allows control over the mouse and keyboard to automate tasks. And we use the PyAuto GUI functions to simulate mouse cursor movement and mouse clicks and keyboard presses. For example, the code on that side simulates a series of key presses to boot up the Windows Ease of Access keyboard for the user on the Windows laptop. And we also implemented the PyAuto GUI library with the headset so that, like I mentioned before, when the user smiles, then the mouse cursor moves up, or when they wink with their right eye, then mouse cursor moves to the right. And when I was working with the PyAuto GUI library, I encountered an issue with the screen resolution because the program had to be run on several different laptops as we were testing our code. We ran into problems because the size of the gaps between the keys on the virtual keyboard was different depending on the screen resolution. So that often caused the program to malfunction.
Yeah, so I'll be talking about some more problems that we actually had. So a big part of our project was trying to use the headset in order to essentially get facial commands and display them. So our original plan was actually to get both mental and facial commands. So mental commands, for example, if you think push then or pull, then the keyboard would, or the mouse would move like right and left. And if you like blink, then it would click. But unfortunately, we couldn't get both streams of data running at the same time. They run on two different files, and we tried integrating them in multiple ways, but that wouldn't work. So then I also tried running both the scripts at the same time on my laptop, but without some really heavy like server management or anything like that, it wasn't possible. And given the constraints of our project, we weren't able to do that. And then another issue we had was our data was in the form of a JSON, and we weren't exactly sure where it was printing out in our code. So we have to really go through all of the code and all of the Cortex code that they gave. So they gave basically like a library, and then we used the methods in that library. So we did look through all of their methods that they gave us and try finding where the output was. That took a really long time. And another thing was that this headset is really good at some points where the Eeg quality is good, but it also takes a really long time for that to happen, and the Eeg quality was very shaky. I'm going to show you my demo later, and in order to get the Eeg quality to that level, it took about half an hour to 45 minutes of like fine-tuning it and filling around with it, just trying to get it work. So it took like almost half the class, if not the full class, to get it started in the beginning. Like Roger mentioned before, we had a lot of connectivity issues, we had battery issues with the headset. You know, trying to get credentials to call the API information was a pain because every time we pushed to GitHub, pulled onto another computer and tried using the same credentials. Obviously, it wouldn't work. So we had to keep redoing our credentials every single time if we kept pulling the different laptops and stuff. And then, like Roger mentioned again, the example.py code didn't really work, so we had to change all of it. And another thing we had wasn't really a problem, but overall like a structural flaw with our problem, our project, was that it doesn't really work well with the specific application of a keyboard. Because an issue I found, and you'll see it again in the demo, is that every time you tried clicking something on the Windows Live keyboard, it would keep closing down, so to keep opening it up again, which is just really, really dumb on the Windows part for doing that. Like, I don't know why, there's no function to like pin it onto the screen or whatever, but I mean, I couldn't really control that. So, in that aspect, the project didn't really work that well, but other than that, we managed to get everything. So I will show the demo. And I'll be explaining it as it goes on. So as you can see here, I am first querying the headset and I'm starting up the command. And this right here is an example of the JSON data. I'll pause it. Oops. Yeah, so this right here is our Eeg Quality insight, which basically you can see how the Eeg Quality is right now. So right now I'm functioning at 100%, and like I mentioned before, it took a really long time to get to this spot. So then what I'm going to be doing is I opened up, basically this is the live expressions where you can look at my face and you can look at this and it should mimic my face in this. So yeah, look here. So when I blink, it blinks, and I move my eyebrows, it moves it up. So if you look at it that way, it works pretty well on this one. So that's what like basically our proof of concept was originally. I was like, oh my god, it actually works really well compared to mental commands. So that's why we opted for facial commands over mental commands as well. So and then after this, I decided to try it on the actual terminal. This is like some of the part of the code we wrote to start printing all this stuff out. So this is in the form of JSON. And when I blink, it should change it. And right here, when I blink, the mouse is right here. You can see it, and it's moving. So it's basically how it works. So every time you blink, it would move it. Fast forward a little bit. All right. Now this is the actual demo of me trying to do the thing. So I sped it up a little bit because it took a really long time. And sometimes, as you can see, the keyboard kept like shutting down after a little bit, or because it wasn't like fully working. So it was a little bit janky, but eventually I managed to type out the word type. So yeah, it took a little bit, as you can see. I think the full clip was like 2 minutes long. So it was kind of long, but yeah, eventually we got there.
So here are something that we learned by working on this project. So the first is about teamwork. I think especially for me, because I worked on like individual projects last year and in the fall term. So it's a really good experience to work with other people. So the first thing that we learned is that dividing the project into many, I guess, subtasks help us to work together very well. So in this case, I worked on Cortex API, and SRUTI and Daniel and ADVAITH worked on something else. And in terms of communication, I think that we also did a good job in terms of discussing the progress of each of our tasks in class. And GitHub also helps us to collaborate with each other by updating our code to GitHub and basically get it when we need it.
Yeah, so then the other thing we learned was also how to learn code in Python. So I had experience in this before, but other members of my group have not had as much experience coding in Python. So I think it was really helpful for all of us to sort of sharpen our skills in Python, learn how to read Python, also go through like documentation, trying to decipher that, because that's also a big portion of coding in the real world is looking at documentation. and looking online and using your resources to your advantage. So we learned a lot of stuff like that as well.
So lastly, which is one of like the biggest things, we learned how to read EEG data and analyze it, but also combining like this entire world of psychology with computer science was a big thing. Like we spent a lot of time researching about the headset itself, and luckily the headset came with a lot of like already written code for training it, as well as a lot of documented information on how it actually works. So that's something that we learned.
Would you see a sort of real world use for an application like this instead of something like speech to text for typing or other possible alternatives?
So you mean like other real world applications with a headset?
Yeah, would you, this kind of thing, like headset to typing, would you see
Yeah,
this being
I mean,
used?
I think it could be useful. Like it's been used before. So if you know Stephen Hawking, he did something really similar. It's kind of where I got the idea from, like facial expressions. He used to like wink and like do the only stuff with like his like right eye to like move a cursor kind of, or like a laser or something, so you can point to different objects. So we kind of use a similar idea. So yeah, I can see it being used. But something actually Elon Musk said was that trying to use an EEG headset was like trying to listen to a recording from outside the studio. So I mean, maybe the more viable option is like his Neuralink, but I don't know. I think EEG technology is still really cool, and it probably is going to have a bigger place in the world soon.
What you mentioned the Stephen Hawking connection. Was that your inspiration? Like, what gave you the idea, the inspiration to try this out and just try researching for the headset and then come up with the idea to try this out?
Yeah, I mean, I had multiple inspirations. So Stephen Hawking angle was part of it, of like the actually doing the facial expressions part, but the overall project, I watched this YouTube video of a guy using an EEG headset. So I saw that and I thought it was really interesting. So then I decided I wanted to do something similar because it looked pretty cool, like controlling something with the EEG headset. I was like, oh, I think that's a pretty cool idea. And we got here thanks to you. We got headsets.
Did you have to pitch your idea to your teammates? Like, how did that work?
Yeah. So I first went to Mrs. Wolf, asked her about this idea, and then I got directed to you. Had an email with Mrs. Wolf, and then I went to my teammates and asked them if they would like to join me. That's it.
How do you feel about the project in the end? Do you feel like it was a success in terms of I saw what you talked about, what you learned and the teamwork and whatnot, but how do you feel about it?
I think overall, like I learned a lot about like working with each other in a team, and also like the coding part of it, because it's a bit different with Cortex API, which is something that I didn't know before. And I think although we have like lots of room for improvement, especially considering that the speed of typing is very slow, I think we can like work on that next time.
Still feels like a success?
I think in terms of the project, it's probably not what we expected to be our outcome, but we also didn't realize how many problems that would have came with it, as well as the several weeks spent researching the project itself. So I think there's always room for improvement, but like Roger said, I think overall as a group, I think it was successful, maybe not the outcome of the project.
Would you have done anything differently if in terms of structuring the project or along the way, besides having it just be a better, the EEG technology be better and the typing be faster?
I mean, I think that one thing we could have done better, I think, was in the beginning, we were sort of a little confused on what exactly we were doing. I think if we could expedite the research process next time, I think it would go better, because it took like, since we were the first group to like really like do something with this, we didn't have any like background, and even though we had like the documentation of the Cortex API, it wasn't the greatest documentation in the world, and general websites like Stack Overflow didn't exactly have a lot on like Emotiv headsets because they're very, very niche. So like in terms of like guidance from the outside world, it was very little. So I think I don't know, something like future groups want to do this project. I think since we've already done it, we have like our journals and stuff, so they can look at our journals to see if they can help them as well.